Welcome to all of you. In this lecture, class 11th, today we will start the unit 2nd, motion in a straight line. Okay, so our today the second unit is motion in a straight line, and actually you have already studied about chapter motion in class 9th. In class 9th, motion in a straight line and distance, displacement, speed, velocity, and slope of speed time graph, slope of distance time graph, slope of velocity time graph, acceleration, uniform, non-uniform acceleration, Newton's equation of motion for uniform acceleration, all in class 9th you have studied earlier. Okay, so in class 11th we will discuss some more about this chapter, motion in a straight line, and we will derive the Newton's equation of motion here by calculus method and slope for non-uniform motion also. Okay, so we will discuss in detail about this chapter in as a position, sometimes position of an object as a function of time, and velocity, acceleration as well. Okay, means how the position of an object is changing with respect to time, how velocity is changing with respect to time, we will study. Okay, so first of all, we discuss about the basics of this chapter. Okay, from the basic. Okay, and in the on the basis of your previous knowledge about the motion. Okay, so first off, I want to tell you that mechanics, actually what is mechanics, and in case of mechanics we will discuss about statics, dynamics and kinematics here. So first of all, mechanics is the branch of physics. Mechanics is the branch of physics which deals with state of rest and motion. State of rest and motion. So what is mechanics? Mechanics is a branch of physics which deals with the state of rest and motion. Okay, and then in this we discuss about statics is there. Okay, and what is statics? Statics is the branch of physics. Okay, is the branch of mechanics in which we study about the rest position of the object. Okay, means equilibrium position. So in this way state of rest is discussed. Okay, statics means the state of rest of the object. Okay, in this branch you can write in detail, means in this branch of statics is a branch of mechanics in which we study about the state of rest of the object. Rest means equilibrium position. Rest means equilibrium position of the object. Okay, now kinematics, or we can say dynamics generally. Okay, dynamics and kinematics. So I am writing here first kinematics. Okay, so what is the kinematics? It is also a branch of mechanics in which we study about the motion of the object but without the cause of motion. Okay, means mechanics deals with the state of motion of the object, Okay, mechanics deals with the state of motion of the object but without cause. Okay, without cause of motion. Means in kinematics we study generally we will study about the state of motion of the object but without cause of motion. Means without cause of motion means actually what is the cause of motion? You know, for moving any object we have to apply some force. So force is the cause of motion. But kinematics we generally it is the state of motion, but we will not discuss the cause of motion in kinematics. Okay, cause of motion generally you know, cause of motion is force. Cause of motion is external unbalanced force. We can say external unbalanced force. So we will not discuss about the cause of motion in kinematics. Okay, then next one is dynamics. Okay, so before telling about dynamics, actually what we will discuss in kinematics we will discuss about the position of the object or the velocity of the object. Okay, means it is a state of motion, means how position is changing with respect to time, means speed of the object, velocity of the object. We will discuss about acceleration of the object also, but we will not discuss about the force. Okay, so next branch is dynamics. So in dynamics, it is the branch of the mechanics in which we study, or we can say dynamics deals with the state of motion, with the state of motion of an object, state of motion of an object with cause of motion also, with cause of motion also. Means in case of dynamics we will study about the state of motion and with cause also, means the cause of motion we will discuss in the dynamics. Okay, so these are mainly the about this chapter. Basic thing, mechanics is a branch of physics which deals with the state of rest and motion. Statics, state of rest, deals with the state of rest of the object, means equilibrium position of object. Kinematics deals with state of motion, the object without state of motion of the object without cause of motion, means no cause of motion. Okay, dynamics deals with the state of motion of an object with cause of motion also, means in case of dynamics cause of motion is force. Okay, force, we will discuss about force, we will discuss about linear momentum. Okay, when the object moves with linear momentum, right? You know from class 9th, rate of change of momentum is a force. Okay, then we will study about work. Okay, if there will be force, then there will be some work and there will be some energy, power, like this we will discuss in dynamics. Okay, so now you can note down this one, then you can take a screenshot for this. Okay, now kinematics. What is the kinematics? Kinematics means means motion. I am again explaining kinematics in short. Kine means motion and matics means mathematics. Okay, so here kinematics means motion in mathematics in motion. Here we can say mathematics used in motion. Okay, or mathematics in motion. Generally in kinematics we will apply the mathematics for the solving the problems of motion or for describing the motion. We will in kinematics we will describe the motion of an object with the help of mathematics. So that's why it is called kinematics, but no cause will be there. Okay, so now this is the basic idea of this chapter. We will go step by step, okay, on the basis of your previous knowledge. Okay, I am taking some previous topics. Okay, and next one is a rest and motion. Rest and motion. Actually, what is rest and what is motion? So how we can define rest position? We have to need some frame of reference. Okay, means suppose I am here at this position, so this is the board, suppose. So if I am not changing my position with respect to this board, I am stationary here, means if I am not changing my position with respect to this board, then I can say I am in the rest position. Okay, when an object does not change its position with rest as time passes, okay, then it is called rest position. So rest we can define when an object does not change its position as time passes, does not change its position with respect to a reference point, or we can say a reference frame. Okay, reference point or reference frame, then as time passes, okay, means change in time is there. As time passes, then the object is said to be in rest, is said to be in the state of rest. means any object is not changing its position with respect to any frame of reference or any reference point as the time passes, then it is called at the position of rest. Now in case of motion, what will be, you can note down the definition of rest, okay, and I am writing, changing in this definition for describing the motion. And what will happen in case of motion? When an object does not change, we can say that when an object changes its position with respect to a reference point or reference frame as the time passes, then the object is said to be in the state of motion. Okay, so this is about the rest and motion. Okay, whenever any object changes its position, then with respect to any reference point, as time passes, then it is called in the position of a state of motion. Okay, now one thing is there, are rest and motion absolute or relative terms, or relative means, this is the thing, are rest and motion absolute or relative? Okay, means rest and motion are absolute or relative terms. So please see here, suppose this is a bus, okay, this is a bus, and suppose this bus is moving with a certain velocity 60 km per hour, or we can say like as 30 km per hour. A bus is moving like as a speed 30 km per hour. Suppose there are two objects, two persons, we can say two persons A and B, and they are sitting inside the bus, okay, and they are inside the bus, and suppose here an observer C, okay. So the bus is moving, then the observer C will observe that the A and B, both the persons are in the position of, in the condition of moving, in the state of motion, okay. For observer C, these two will be in the motion, okay. But for object A, suppose we say that the object B is in state of motion for the observer C, okay, or the person B is in the state of motion for the observer C, but the person B is in the state of rest for the person A. The similar person B is in the state of motion for the observer C, but the same person B is in the state of rest inside the bus for the person A. So we can't define that the observer B in the state of rest or in the state of motion properly, okay, means there is no absolute rest, okay. So there is rest and motion are not absolute. For the person B is in the moving position, moving condition for C, but it is at rest at B. So rest and motion are not absolute terms, they are relative terms, okay. So here you can write rest and motion are not absolute, these are relative terms, okay. So this is about rest and motion, okay. Now in case of motion, okay, there is terms of distance, displacement, so many things, okay. So first, you know about uniform and non-uniform motion. Uniform motion, suppose uniform motion. What is uniform motion? You know, if any object, I can write directly, if any object changes its position, if an object changes its position by an equal amount in equal intervals of time, howsoever so small these time intervals may be, these time intervals may be, then object is said to be in uniform motion. Object is said to be in uniform motion. Means, suppose any object changes its position by an equal amount in equal intervals of time, okay, or vice versa, okay. Howsoever so small time intervals may be, the restriction is there that the time intervals may be small as may be possible, okay. Means that for this should be for small time intervals, okay. Then the object is said to be in uniform motion. And you know from class 9th, the distance time graph for uniform motion. And suppose the object is starting its motion from the rest. Initially that was object at rest position, and that is moving with a uniform, it covering a equal distances in equal interval of time. Then the graph for uniform motion is like this one, okay. We will discuss later on the slope of these graphs here in class 11 in the next lectures. So this is about the uniform motion, okay, and we will discuss it further, okay, in detail also. Next one is the non-uniform motion. Non-uniform motion. What is non-uniform motion? If any object changes its position by an unequal amount in equal interval of time, or we can also say that by equal amount in unequal intervals of time. Means, if any object changes its position by an unequal amount in equal intervals of time, or we can say by equal amounts but in unequal intervals of time, okay. Howsoever so small these time intervals may be, then the object is said to be in non-uniform motion. Then it will become said to be in non-uniform motion. And the graph for non-uniform motion, distance time graph, if we will discuss about the distance time graph for non-uniform motion. So the distance time graph for non-uniform motion is not a straight line passing through the origin. The distance time graph is curved line. You have studied about in class 9th also. Suppose the graph may be like this one, and the graph may be like this one. For distance time graph may be like this one also, okay. So this is about the non-uniform motion, okay. So you can take the screenshot for this one. Okay, I think you have taken the screenshot for this one. Now I will tell you, we discuss about the motion in a straight line, the position of an object as a function of time, okay. So first here in this lecture we will study about motion of an object in a straight line also, okay. We can say this as a motion in one dimension, okay. But we will discuss about motion in 2D, in a plane, motion in a plane in the next unit, okay. That is our third unit. And then we will there is motion in a 3D. So first I am telling you how we can define motion in 1D, 2D and 3D. Suppose an object is moving in a straight line path only in one direction, okay, either x-axis, minus x-axis, plus y-axis or minus y-axis, in a straight line path, then it is one dimension motion. But suppose an object is moving in a plane. Suppose an insect is here and insect is moving in this board, okay. Suppose insect moves in this board in this direction, like suppose. So we need two coordinates to define its position. One from how much distance is covered in the x-axis, in this axis, and how much distance, what is the position, and how much distance is covered in this axis. Means we have need to define two axes. One along this one, how much distance covered, and another one, this one. Also the motion in this is motion in two dimension, motion in a plane, okay. Suppose an insect is flying in this room, okay, in this room. So we have to need three coordinates to define the position of any insect flying in this room. Suppose there is an object, this is an object in this room. So we have need three coordinates to define its position, okay. One along x-axis, you can take the three axes of the room means three corners, where the three corners of a room meets. Okay, one along x-axis, how much distance, and along y-axis. Okay, and on the second axis, how much at how much distance it is, and we have need also a third coordinate, means the height. Okay, means three coordinates. We need three coordinates to define its position. That is motion in 3D. But here in this unit we will describe or we discuss about the motion in straight line path. Okay, so suppose, let's see here, an object is moving along a straight line path along x-axis, okay. So initially suppose at t1 second, what is the position of the object? Suppose the position of the object is x1. So at t1 second, how we can represent the position of the object? We can write that as xt1 equal to x1. What is the meaning of xt1 here? The meaning of xt1 is not that the t1 is multiplied by x. No, this is not the meaning. xt1 means I written here the t1 in the bracket. It means the position of the object x at t1 second. xt1 means the position of the object at t1 second. That is, I can write as x1. Okay, but you can see, suppose the object is starting from the origin, means beginning point. Suppose t1 is 0 second. Okay, so t1 position of the object we can write simply the position of, I am explaining in detail, position of object at t1 second equal to, we can write as xt1. Position of object at t1 second means xt1. We can also write xt1 equal to x1. This is the meaning. Position of object at t1 second we can write as x1. Okay, xt1 equal to x1. Now suppose the object is at t1 is 0 second. Okay, means the object is initially at rest. Okay, we are taking from this position. So xt1, okay, equal to 0. But we have taken it 0 second. So we can write x0 equal to 0. So this is not the meaning at t1 equal to 0 second. At t1 equal to 0 second, position of object is written as x0. x0 means not the meaning that x multiplied by 0 equal to 0. This is not the meaning. The meaning is that the position of the object at 0 second is 0. Okay. So here simply we can write the position of object at t1 second xt1, or we can write xt1 equal to x1. Suppose t1 is 0 second, we just started our stopwatch. Okay, so x0 equal to 0. Now after some time t2, the object is moving like this one, and object reached at this point, okay, p. So at t2 second, p is the position of the object, and here you can note down t2 is greater than t1. So how I can define this position? I may write position of object at t2 second. Position of object at t2 second equal to, I may write xt2, means xt2 means position is a function of time at t2 second. Okay, and I can also write xt2 equal to x2. I may write this one xt2 equal to x2. Okay, now in general xt2 equal to x2, and we can represent by it as op, means this is the x2, means the displacement of the object from this point O to P. Suppose this is O, then I may write here OP. Okay, and this is the thing. Now what is the change in the object position? Okay, we can write here in delta change in time. Okay, change in time. We can define change in time as delta t equal to final time minus initial time, means t2 minus t1. Okay, and in delta t time, in delta t time the change in position of the object, change in the position of the object in delta t time, the change in the position of the object, we can write that delta x. Delta x is the change, and what is the change? The final position is defined as either xt2, we can write the final position xt2 minus initial position xt1. We can write this one as xt2 minus xt1. Okay. Or then what will be the, this is the in delta t, the change in the position of the object, we can write the change in the position of the object in delta t time interval. Okay, so this change will be delta x equal to xt2 minus xt1. So what will be the change of the object in 1 second? Suppose in delta t time, you can see from here the change in position of the object is xt2 minus xt1 in delta t time. So what will be the change in the position of the object in 1 second? So we will divide the delta x by delta t. Unitary method will be there. So you can note down, you can take the screenshot of this one, then we will discuss further. Okay. So you can check. Okay. Now this is the change in delta t time, the change in the position, the change in the position of the object in 1 second. Then this will be become delta x upon delta t. Okay, and this will be delta x means we can write xt2 minus x t1 upon t2 minus t1. So change in the position of the object in per unit time. So we know this is, we know as average speed. Okay, so this will be average speed, or we can say v bar also, average. So v bar equal to x, average speed will be xt2 minus xt1 upon t2 minus t1. Now we will define it like this, in this way. But you can see here we have written v average equal to, suppose xt2 is x2, xt2 is x2 and xt1 is x1, then xt2 we can write x2 and xt1 as x1 upon t2 minus t1. Okay, we can also write this one as t2 minus t1 in some time. Okay, and suppose we are taking t1 is 0. Suppose if t1 is 0, then x1 is 0, means x at that position we have started from the initial position, means object at rest position. Okay, suppose x1 equal to 0, then what will be in this case? In that case we can write x2 equal to x, means initially the object was at rest. You can assume that suppose initially object is rest, means t1 equal to 0 we can write, and there is no position change in position, x1 equal to 0, we are starting from the rest position. Okay, then it got some time interval t2, then means at time interval t2 we can say at time t also, then its position is x2. Okay, x2 from here to here, this position x2, we can say this position x2 as x also. So what does the mean? The meaning is that we can write v average equal to, suppose x2 equal to x minus x1 is 0 upon t2 is t minus 0. We can also write in this form also. So how we can represent the average velocity? The position of the object at time t2, xt2 means the main thing is the position of the object at time t2 minus the position of the object at time t1 upon t2 minus t1, or xt2 means x2 minus x1 upon t2 minus t1. So this is the delta x upon delta t, means the change in the position of the object in the total time interval. In the total time interval, that's why it is called the average speed of the object. If we restrict ourselves to for a small interval of time, very small interval of time, means delta t tends to 0, very small intervals of time, then we will call it delta t tends to 0, means instantaneous speed. Okay, so then the object, it will become as v equal to dx upon dt, and we call as instantaneous speed. And instantaneous, you can take the screenshot for this one. Okay, I think you have taken. So instantaneous speed is measured by the odometer of a car. Suppose if delta t tends to 0 for instantaneous means very small movement of time, or a small interval, you can say for a very small interval of time, we can write instantaneous speed v equal to limit, we can say limit delta t tends to 0 delta x upon delta t. Okay, instantaneous speed, you know, generally we defined in the differentiation lecture also, mathematical tools in physics, v equal to dx upon dt. This is the instantaneous speed of the object. Okay, so you can note down this one. In today's lecture we discussed about the basics of the chapter motion, and in further lectures we will discuss about the uniform motion in the form of graphs. Okay, in the form of graph for uniform, non-uniform, and for the acceleration. Okay, so that's all for today's lecture. Thank you so much.